Hold up your hand in front of your face. What do you see? You see skin. You see lines. You see a solid object that obeys your commands. If you clap your hands, they stop. If you touch the table, it feels hard. You trust your eyes. You trust your fingertips. But I have to tell you something that might make you a little uncomfortable. Your eyes are lying to you. The human eye is a biological camera. But it is a terrible camera. The electromagnetic spectrum, a full range of light that exists in the universe, is massive. It stretches from radio waves, the size of buildings, to gamma rays, smaller than atomic nuclei. And out of that entire massive spectrum, do you know how much humans can see? 0.0035%. That is not a typo. That means that 99.9965% of reality is completely invisible to you. Right now, as you sit there are Wi-Fi signals passing through your chest. There are neutrinos from the sun zooming through your skull. There is a gravitational wave from a black hole collision stretching your room by a fraction of an atom. You are swimming in a chaotic, vibrant, loud ocean of energy. But to you, it looks like empty air. We are walking around with a blindfold on, peeking through a tiny pinhole and calling it the world. But what if we could take the blindfold off? What if we could upgrade our software? What if you could learn to visualize the machinery that runs the universe? Today, we are going to do exactly that. We are not going to look at math equations. We are not going to talk about chalkboards. We are going to build a mental simulator. We are going to learn how to visualize the invisible. We are going to zoom in past the skin, past the cells, past the atoms, until the solid world dissolves, and we see what is really there. If you want to join us on this deep dive into the nature of reality, and if you want to make sure you don't miss the next time we break the universe, when I say nanometer, your brain just turns it into a very small thing. So, let's use an analogy. Imagine you are holding an orange. If you wanted to see the atoms inside that orange, you would have to blow the orange up until it was the size of the Earth. If the orange is the Earth, then the atoms inside it are the size of cherries. That is how many atoms are in a single piece of fruit. Now, pick up one of those cherries, the atom. We are taught in school that an atom looks like a little solar system, a nucleus in the middle, and electrons orbiting around it like planets. This is the Bohr model. It is the most famous image in science. It is also completely wrong. If you want to visualize the quantum world, you have to delete that image from your brain. Atoms are not solar systems. They are cathedrals of emptiness. Let's visualize the scale properly. Imagine we take the nucleus of the atom, a proton and neutron, and we blow it up to the size of a basketball. We place that basketball in the center of a football stadium. Where are the electrons? Are they in the stands? No. If the nucleus is a basketball in the center of the field, the electrons are tiny gnats buzzing around the parking lot outside the stadium. Everything in between the matter is 99.99999999996% empty space. This means that if you remove the empty space from the entire human race, all 8 billion of us, and just pack the solid matter together, the entire human population would fit inside the volume of a sugar cube. So, here's the visualization challenge. Look at your hand again. It looks solid. It blocks the light. But now, turn on your quantum vision. See the billions of stadiums. See the tiny basketballs floating in the void. Why can't you put your finger through the table? If it's mostly empty space, Why doesn't it pass right through like a ghost? Because of the force fields. The electrons in your hand are negatively charged. The electrons in the table are negatively charged. Like magnets, when you try to push the north poles together, they repel. You have never actually touched anything in your life. When you touch the table, you are hovering a tiny distance away from it, about 1 angstrom. You are feeling the electromagnetic repulsion of the electrons. You are feeling the force field, not the matter. So visual number 1, the world is a hologram made of force fields floating in a vacuum. Solidity is an illusion created by resistance. Chapter 2, the fan blade, visualizing the electron. Asterisk asterisk. Okay, we have the empty stadium. We have the basketball in the middle. Now let's look at those gnats in the parking lot. The electrons. This is where the visualization gets weird. In the old model, the electron is a tiny ball whizzing around in a circle. But in the quantum world, things don't have a location until you interact with them. The electron isn't a ball. It's a cloud. Imagine a ceiling fan. When the fan is off, you can see the individual blades. You can point and say, the blade is there. But when you turn the fan on to high speed, the blades vanish. They become a blur. If you try to stick your finger into the fan, you will get hit. It doesn't matter where you stick your finger. The blade is effectively everywhere in the circle at once. It has become a solid disk of energy. This is how you should visualize an electron. It isn't a planet orbiting a star. It is a shell of probability. It is a spherical standing wave vibrating around the nucleus. It's like a bell that is ringing. The sound of the bell isn't in one spot. The sound is the whole shape of the bell. The electron is the vibration. This is why atoms have different shapes. In a hydrogen atom, the electron cloud is a sphere. But as you get to more complex atoms, the shapes get crazy. They look like dumbbells. They look like donuts. They look like flowers made of balloons. These shapes are the orbitals. They are the regions where the electron exists. So update your mental simulation. Instead of a solar system, imagine a 3D geometric cloud that is shimmering and vibrating. It's a misty, neon-colored blob of energy that can change shape instantly if you add energy to it. When you heat up a piece of metal and it glows red, what you are seeing is the electrons absorbing energy, jumping to a bigger fan speed, a higher orbital, and then falling back down, releasing a packet of light. You are seeing the quantum jump. Chapter 3. The ocean, visualizing quantum fields. Asterisk asterisk. Now we are going to take the biggest step. We are going to delete the idea of particles entirely. For a long time, we thought the universe was made of Lego bricks. We thought, here is an electron brick. Here is a quark brick. Here is a photon brick. But this created problems. If an electron is a brick, how can it appear and disappear? How can it turn into energy? The modern way to visualize the universe, the most accurate map we have, is called quantum field theory, QFT. Here is the visualization. Imagine the entire universe, every inch of space. Inside your atoms, in the empty space between stars, is filled with fluid, but not just one fluid. Imagine dozens of different transparent fluids, all layered on top of each other, soaking through each other. There is an electron fluid, the electron field. There is a photon fluid, the electromagnetic field. There is a quark fluid. These fields are everywhere. They are quiet. They are calm. But if you slap the surface of a fluid, what happens? You get a splash. You get a ripple. That ripple is a particle. This is the mind-blowing truth. Asterisk asterisk particles are not things. Particle. Think about a wave in the ocean. Is the wave a separate object from the water? Can you reach in, pull out the wave, and put it in a bucket? No. The wave is just what the water is doing at that moment. If the wave crashes, the water is still there. This explains how matter can be created and destroyed. When particle colliders, like the Large Hadron Collider, smash things together, they aren't breaking open rocks to see what's inside. They are slapping the fields as hard as they can. They smash two ripples together so hard that the energy splashes over into other fields. The energy from the electron field splashes into the Higgs field, and suddenly pop, a Higgs boson appears. It isn't empty. It is a boiling, bubbling soup of fields. Even in a perfect vacuum, these fields are vibrating. Virtual particles are constantly popping into existence and disappearing again, like foam on the top of a latte. You are not made of frozen clay. You are a standing wave in a cosmic ocean. You are a disturbance in the force. We have looked at the very small. Now we must look at the invisible fabric that holds it all together. We need to visualize gravity. If I asked you to visualize gravity right now, you probably imagine an invisible rope. You imagine the Earth pulling the moon. You imagine the sun holding onto the Earth like a child holding a balloon string. This is how Isaac Newton visualized it. But Albert Einstein taught us that there are no ropes. The Earth is not pulling you down into your chair. A classic analogy is the rubber sheet. You've seen this. You put a bowling ball, the sun, on a trampoline, and it creates a dip. If you roll a marble, the Earth, past it, the marble circles the dip. To truly see gravity, you have to visualize the waterfall. Imagine space isn't empty. Imagine it is a river of clear water. Far away from any planets, the water is still. But matter, like the Earth, acts like a drain. The Earth is constantly sucking space itself towards it. Picture the space around the Earth flowing inwards, rushing toward the center of the planet like a 3D waterfall coming from every direction. Now imagine you are a fish, an apple, floating in that river. You don't have an engine. You aren't swimming. You are just floating. But the river is moving. So you move. You start drifting toward the Earth. You pick up speed. You crash into the ground. Did the Earth pull you? No. We call it space-time for a reason. You cannot separate the two. In fact, the gravity you feel right now, the heaviness in your legs, is mostly due to the bending of time, not space. Imagine you are in a car driving due north on a flat sheet of ice. This is you moving through time. Even if you keep the steering wheel perfectly straight, visualize the grid lines of reality, twisting and warping around every object with mass. You are sitting in a gravity well. Time is ticking slightly slower for your feet than it is for your head, because your feet are deeper in the stream. You are not standing on a rock. You are surfing a curvature in the fourth dimension. Chapter 5. The Ghost in the Wall. Visualizing Quantum Tunneling. Asterisk, asterisk. Now that we understand the geometry of the big, let's go. This is called quantum tunneling. In the classical world, the world of marbles and bricks, if you roll a ball at a hill, and the ball doesn't have enough speed, it will roll halfway up, stop, and roll back down. It cannot get to the other side. It is physically impossible. But remember Chapter 2? The electron is not a ball. The electron is a cloud. It is a wave of probability. Most of the cloud is in one place, but the tail of the cloud spreads out to infinity. So visualize the electron approaching a wall. The center of the cloud hits the wall and bounces back. B-U-T. A tiny, ghostly wisp of that cloud extends through the wall to the other side. There is a 99% chance the electron bounces back. But there is a 1% chance that the electron is actually in the tail. If you wait long enough, or if you throw enough electrons at the wall, eventually one of them will just appear on the other side. It doesn't break the wall. It doesn't drill a hole. It simply ceases to exist on side A and instantly exists on side B. It teleports. You might think, okay, that's a cool magic trick for atoms, but does it matter to me? It matters because without it, you would be dead. In fact, the sun would not shine. Visualize the center of the sun. It is a fusion engine. It smashes hydrogen atoms together to make helium and release heat. But hydrogen nuclei are positively charged. They hate each other. They repel like magnets. The sun is hot, but it actually isn't hot enough to push the atoms together against that repulsive force. According to classical physics, the sun should be dark. The atoms should bounce off each other forever. But they don't, because of quantum tunneling. As the atoms get close, they hit that invisible wall of magnetic repulsion. But every once in a while, a hydrogen atom borrows energy from the future, becomes a ghost, tunnels through the repulsion barrier, and fuses. It happens rarely, about once in a billion years for a specific atom. But because there are so many atoms in the sun, it happens enough to light up the solar system. The light hitting your face right now is a result of particles walking through walls. So visualize the sun not as a fire, but as a massive quantum lottery machine, where trillions of ghosts are phasing through barriers every second to keep us alive. Chapter 6. The Invisible Wire. Visualizing Entanglement. Asterisk, asterisk. We have one final visualization to build. The one that Einstein hated. The one he called spoopy action at a distance. Quantum entanglement. This is the hardest one to picture because it breaks the rule of space. We are used to things being separate. I am here. You are there. If I want to affect you, I have to send a signal, a sound, a radio wave, a pigeon. That signal has to travel across the space between us. Entanglement laughs at space. Here is the standard wrong analogy. You have a pair of gloves. You put the left glove in a box and the right glove in a box. You mail one to Tokyo and one to New York. If you open the New York box and see a right glove, you instantly know the Tokyo box has the left glove. That's not magic. That's just logic. The gloves were always left and right. But quantum entanglement is weirder. It's like putting two spinning coins in the boxes. While they are in the boxes, they are not heads or tails. They are spinning. They are undetermined. But they are spinning together. Their probabilities are linked. Now, you open the New York box. You stop the coin. It lands on heads. Instantly, at the exact same femtosecond, the coin in Tokyo stops spinning and lands on tails. It doesn't matter if they are a mile apart or a galaxy apart. The choice made by one coin instantly forces the choice of the other. No signal traveled between them. It happened faster than light. How do we visualize this? Don't visualize two objects connected by a wire. Visualize one object that has been stretched. Imagine the universe is a folded piece of paper. In our 3D view, the two particles look like two separate dots on the paper, far apart. But in a higher dimension, the quantum dimension, the paper is folded so that those two dots are actually touching. They aren't sending a signal across space. They are effectively in the same place. This means that distance is a construct. It means that at a fundamental level, The universe is much more interconnected than it looks. When two particles interact, they become entangled. They lose their individuality. They become a single mathematical system. And since all the matter in the universe came from the Big Bang, a single point technically, everything is entangled with everything else to some degree. Visualize the universe not as a collection of billiard balls, but as a massive shimmering web of connections. When you move your hand, you are tugging on invisible threads that stretch to the edge of the cosmos. The new I ***. So, let's put the blindfold back on. Let's open our physical eyes and look at the room again. It looks the same as it did 10 minutes ago. The wall looks solid. The air looks empty. The sun looks like a yellow ball. But you are different, because now you have the dual vision. You can overlay the simulation we just built. Look at the wall. Now dissolve it. See the stadiums. See the vibrating electron clouds. See the 99% empty space. Know that the only reason you can walk through it is because of the electromagnetic shout of the atoms. Look at the air. See the ocean of fields. See the virtual particles bubbling in and out of existence. Feel the weight of your body in the chair. Visualize the waterfall of space-time rushing downwards, bending the future toward the Earth. And look at yourself. You are not a solid object. You are a complex pattern of energy, a ripple in the quantum field, held together by forces you cannot see. Powered by the tunneling of ghosts in a star 93 million miles away. The invisible world is not out there in a lab. It is right here. It is you. Albert Einstein once said, "Reality is merely an illusion, albeit a very persistent one." He was right. But what a beautiful illusion it is. Now that you can see the machinery behind the curtain, the world will never look quite the same again. Keep looking. Keep visualizing. And remember, nothing is as solid as it seems. Thanks for watching.